Good morning, good afternoon, good evening. This is David Singleton. I'm your moderator today. We have a presentation by Luc, and the topic is interface-based injection and test automation in VC, our 58th webinar. And Luc is going to give you this nice presentation today. So basic rules, I'm sure you all know them. Your mic is muted. If you have a question, please go to the question window, type the question in there. If the question is something I can answer, I'll answer it immediately. If it's something that needs Luc's involvement immediately, I'll interrupt his session to carry on. And otherwise, we'll have a Q&A session at the end, which I will manage through. So just a quick reminder that all of our sessions are recorded and published on the YouTube page, the YouTube Areopa webinars. Please like and subscribe, all the usual stuff, because that's what we need to be able to move forward. We also have a newsletter. If you've signed up to the newsletter, then you will be getting invites to all of the sessions as they come along. We have a fairly packed calendar. We have a few gaps, but we have some of our favorite speakers. We have Stephen Renders, who is our Power BI expert, and he will be giving some quite a different topic to me. I haven't seen what this is, but it looks like to be quite a more automation presentation, which could be good. Waldo, typical, very popular presenter, and we'll be talking about something about tooling which is different to what we used to. That'll be nice. Christoph, KB, will be talking about system mapping examples. We have Marcus Lippert and Tobias Fenster together on the CI/CD, and I think that that's going to be pretty good to see, especially for those looking at where to move with DevOps and the future as it's going. We then have Jan Windelal with a presentation from Business Central's user interface. And then we have David Feldhoff going on some regex. So I'm interested in that one. Regex is very interesting, so see how that goes. So right now, I'm going to hand it over to Luc. Let's get going. This should be an interesting session. And please don't forget that we are always looking for new people. If you've got a session, we have one gap before March, and then in April we have a few gaps. But even though we're fairly full, we do want you. And remember, this is a great media. If you want to get out there and have a first go, if you haven't done a presentation before, this is a great starting point. The format of this structure, the way we do it, makes it very easy to get started. So I'm going to hand over to Luc. Before I do, I'm obviously going to thank our sponsor, Fornav, who make all this possible. They do all of our sponsoring, so thank you to Fornav. Luc, over to you.
Yeah, thank you very much, David. And very nice that you could be the moderator of today. Yes, welcome to you all. Today I want to talk about how to use interfaces as a way to replace functionality, what they call interface-based injection. And specifically, I want to show you an example how this is a powerful way of what they officially call test doubling or mocking parts in your test automation. So that's, well, in one line, the topic of today. So a little bit about myself for those who don't know about me. I'm not going to read out loud, but as you know, probably I'm doing a lot around test automation, and that's, let's say, my history started around 20 years ago when I was going into the Microsoft organization when Microsoft acquired Navision at those days. Of course, a short reference to my book, but not just a commercial one, mainly that what I'm discussing here is an extension to chapter 13 in the book, which is talking about how to test your own APIs, but also, let's say that's incoming calls, but also how to test outgoing calls. And that's typically, let's say, the focus of today, where we're going to apply interface-based injection. So the agenda, a short recap on why interfaces and what are interfaces. I will jump through it quite quickly, but just to one hand relate to a session that was recorded 2 years ago by Tobias Fenster as Areopa webinar on interfaces, which were a new concept at that time within VC. And of course, in short, the why and the what of that side. And then I will discuss what interface-based dependency injection or interface injection based injection is, and then I'll discuss how to apply this under the title or within the concept of test doubling. So I took a slide from Tobias' presentation. I tweaked it a little bit, but why do we need interfaces? He took the example of the base application where we have a price calculation part. And yes, nowadays there's a new version on it. There's a lot of discussion around the implementation of it. Nevertheless, what do you do when you would like to replace a component, being price calculation, by a new version, in this case called price calculation with forecast? How would you be able to switch from one to the other, not having to remove old code and move in new code, or tweak things so you can configure things that it's not going to move into or execute the old code but the new code? With interfaces, this is a lot easier, because we, as you could call it, componentize things. A different interface implementation is a different component, although it's used for the same purpose. That's a bit, let's say, the background. And as Toby listed a couple of things, what do? We define a component, and actually we describe what it's doing. We are not describing the implementation. So it's an API. We define the API. What call can you make to the API, and what do you hand over, and what do you can expect to be returned? Yeah. So it's a way also, this componentization, to allow more easy thinking and clearer thinking about the architecture of the solution. We do want here something to happen, and we define the interface between the two, or as we also call it, the contract, and then how it's implemented in the background is something that can be done in different ways. Yeah, and on runtime, we can then replace a component. That's what I'm going to use today also, to switch from one implementation to the other. He took two examples, the German tax calculation versus Danish or whatever, so that you would be simply configuring it by selecting, and that's what I'm going to use today too, a different option, an enum value, and related to that, it will trigger another code part. Yeah. So in this example on the left side, you could say the price calculation blue box with a white outline is going to be override with the orange one, the price calculation with forecast. And yes, we could extend any component. We could add functionality by extending the enum that implements the interface, and implement for a new enum value another interface code unit implementation. I'll show you a couple of examples later on. So in short, what are interfaces? An interface is a contract, a syntactical contract that can be implemented with a non-abstract, as they call it, method. So we define the method, the signature, you could say, or the contract, the name of the method, the parameters of the method, and that's what the interface actually defines. And then we can implement that interface by a non-abstract method, complex wording. So with the interface, we define the capabilities, and yes, with the implementation, we do the coding, not the interface itself, but the implementation of the code unit or the interface. Yeah. An example which I always want to refer to is that we, for a long time already, have a kind of interface on code units, the on-run trigger, including a table number or not. And in that way, we've been doing a lot of implementations that we could switch between code units, referencing another ID. There's a little bit of a sore throat, so I need to cough once in a while. But of course, nowadays it's different, or we have a better way of doing this. We can define an interface, and this is an example, and I use this example a little bit later to do a small demo where I have a person has a first name and a second name, and we want to format that name. And that could be a simple definition here of an interface saying we want to have an implementation of the method formatted name. And the one implementation could return only the second name or the last name, whatever we want to call it, the family name. And another implementation could return the first name, probably not that relevant, but we could have an implementation called full name, which will then give the first name and the last name, or even more extended. And I'll get into a couple of examples. The advantage here is that we define the format, so the behavior, what we want it to do, not how it's going to do, but what it should be doing. And then the implementation would be a code unit implementing this exact method. So this could be an implementation called full name, and here we combine first name and last name. And yes, this is maybe not that nice concatenation, but this is just an example. And yes, as an extra one, I added the feature of a method that reduces spaces. So if there are too many spaces that it doesn't look too nice, let's remove duplicate spaces. But that, of course, is a way of implementing. This is an implementation of that interface iname format. So let's have a short look at that example. So here we see the implementation, or sorry, the definition of the interface, formatted name. I hand over a person record. In this case, in my extension, I've defined a person record which contains a number of fields: first name, second name, last name. And yes, I also added a field where I can select enum version or the enum related to the interface. One of the nice things I think of the interface implementation in BC is that it provides the possibility to link an enum to the interface implementation, so and that each instance of my enum can then be linked to a specific implementation. And this looks like this. We're not going to into all the details of the code. You might have questions, of course, and feel free to post them, and I will answer them. So if we get into the page here of my person table, this is my name, my first name, my second names, and more than one. That's why I call it second names. And my last name, my family name, and this is my youngest brother. And the full name concatenates my first name and my last name. Yeah, so that's a simple, straightforward, implementation, you could say. And yes, what I could do is that I did implement two other versions of the interface, only the first name and a password name. I didn't implement a last name, but I'll show an example of something else that I implemented. So if I select first name, it's only going to pick up the first name. Of course, that's the logic behind the password name. Should then have all my names on it. And this way, using this enum, I'm switching from one interface implementation into the other. So you could say a short recap. By the way, this example of this, well, this, you could say this person extension, I created that one as a prep for the presentation I did at BC Tech Days last September with Nicola. I didn't use that one, but I used the example I will be showing later. By the way, I mean, I already said you could extend it by using a enum extension, and that's what I do in the test here. So that was part of that presentation, also in test automation. Here I implement an enum extension where I add two new options. Yeah, one is called names mock and the other is called names stop. In short, Mocking is what we use, and I will discuss that a little bit later. But mocking is a very specific way of what we call more generically test doubling. And stop is actually a hard-coded replacement of a feature or of a functionality of some code. A mock is a more intelligent one. So if you look here at the implementation of my stop, it's just going to exit with a hard-coded name, yeah, or hard-coded string, while the names mock is actually having some logic and it's going to revert the whole name. So if we would go and implement this, let me turn on my screencast toggle here. So if I'm going to deploy the test, and there are also some tests there, but they're not that important. If we'll have a look at this one here, and now it should show that I have 2 extra implementations available. Yeah, so if I use the stop, and that's for the testing, it could be used like if I use another one, how does it act? Well, this is what it will do. If I use the names mock, the name doesn't reflect it, but it's going to take the full name, the passport name, and it's going to, or it's only concatenating the first and the second names, and it's going to revert it. Yeah, so you can see that there's an easy way of extending the interface implementation already available, let's say in the base app, my person extension, and I've added 2 extra options to the enum and through an enum extension, and I implemented 2 extra versions of my interface. Yeah, and that's actually in a nutshell what interface-based dependency injection is about. I'm enabled to implement another version of the interface, and the easiest way to me is to use that enum list, that listing of the interfaces, and extend it with my own enum instances linking to my own interface implementations. So that's the basics concept. Enlisted, what is dependency injection actually exactly about? Dependency injection lets you replace a dependency by another one. Yeah, and that's if we have a dependency in code on some table or on some code unit or whatever. In general, it's hard coded. We're getting a record in that table. We're triggering a method in a code unit. So in general, the dependencies are set, they're static. We cannot change them. With dependency injection, the idea is write your code this way that the call to a specific method, to a specific process, can be replaced by another one. And with interfaces, we have a quite easy way of doing this. In the past, I already mentioned the code unit with the on-run trigger being a kind of interface avant la lettre, where we could have a table, a setup table, for example, where we could point to a specific code unit that would be the one standard to be executed for whatever process, but that somebody could build a new code unit and that you could reference the ID of that code unit. A big danger with, let's say, that code unit ID referencing is that anybody could select any code unit number, which is probably not going to work, and maybe that's not a big danger, but it could also be any other number referencing a code unit that does something, let's say, fitting, but is going to, well, endanger your data. With enums and interfaces, you have to deploy an extension, and that should be allowed to do, of course, with only specific enum values, so only specific implementation of the interface and not a random code unit or whatever. Yeah. Dependency injection. Interface-based dependency injection already mentioned, but that's what we do when we use interfaces to inject it as a replacement to another one. Yeah, and the example that I showed is with the name that we have already in the base extension. We have a full name, a first name, and a password name. And yes, I can extend my extension with another extension. And the example I had was a test extension where I have two implementations, what I called the name mock and the name stop, to allow it to replace one of the standard ones. Yeah. So this way you decouple the implementations. You have different components that you can one or the other couple, inject into your code flow. And yes, and that's the step we're going to make right now, is that this is of great value in making your code testable. Yeah, I will explain it a little bit more. And as the sentence said, we want often to decouple the test from the real implementation. An example is that we're calling upon external services, and that's also an example I'm going to demo. We want to decouple our automated tests for various reasons. It could be that that service is not available, so our test fails because it doesn't get a response that fits that fits the test flow, and the test fails, which is not because our logic is not working anymore. No, we're not getting a response. So we would like to test double that, or in daily wording more, we use the word mocking still. Or there could also be that our tests do run very frequently, maybe multiple times a day, and we have to pay for the service we're calling. That's probably not a thing we want to do. Or we don't, let's say, a little bit more altruistically, more considering the other side, we don't want to load that system with all our calls. I mean, if it's a service that's being called upon by many tests around the world, you could say it's probably going to overload the server that's servicing that external service. So testable code, to get back to that, is code that allows us to have full control on the execution of that code. So it's code, production code, that is written in such a way that we can take control over or on dependencies. Yeah? That could be simple as providing parameters to a method, so we can provide a different value of the parameter, triggering it in a different way, or that we don't need to go into the database to fetch a record built into that method, but from the outside we're only calling the method to see if the logic works right, and we don't want it to fetch anything from anywhere. That's a simple way. The more complex one is using, for example, an interface definition, and that we change the enum we're using, the value we're using, and in such a way we switch from a production implementation of an interface into a test double of that interface. So test doubling, with a test double, we create a stand-in component for the real one. Yeah? The name, by the way, was made up by Jared Matsaros, the one that set up the XUnit test patterns, for those who know about it. And he called it a test double in parallel to what we see in movies for stunts, that we have stunt doubles. Yeah, that's the way he started to call it, a test double. And yes, in general, we call it a mock, but a mock is a very specific implementation of a test double. It is a replacement, but it has logic in it. So depending on the context you're using in it, it will yield another result, while a stub and also a dummy will always yield the same result. For those who have my book, in chapter 12 and 13, I'm discussing test doubles, etc. So you can read more about it. Yeah, with the test double, we make our tests independent of the real component. So like in my example here, although this is not an automated test, but you could call it a test, I can see that indeed when I switch, another evaluation is done. Of course, this is a very straightforward one. I'm just switching from one to the other interface implementation, getting another result. But the idea is exactly the same. I will show another example a little bit later, and there it's more complex, where deeper into the code, there is a call upon the interface, and that's the one we can steer. So the whole logic will be executed before it gets to that interface call, and that's what we want to test. Do you get to that interface call, and does everything work right? And when the interface call is executed, is the result also handled right? So what I'm going to show you is also a call to a web service, and let's say mocking test doubling is often wanted to be used in the context of our code calling an external service. On the other hand, you could also mock data. I mean, if you run a report, if you want to test a report which is based upon historical data, let's say ledger entries, you might maybe think like, oh, before I can run the report, I need to post a document or a journal, and that get sufficient ledger entries that allows me to run the report and see that the report displays it right, and that it picks up the ledger entries, and that it's indeed going to show me a nice display in the report. However, you could also decide, let's just create hard-coded a number of ledger entries. That saves you a lot of time. Filling up a journal and posting a journal is surely going to take somewhat longer. And maybe it's not that a lot of time and not worth to mock the data, but mocking test doubling is also used for data sites. So you could take this a little bit wider than just replacing a call to another service. Yeah, and the purpose in general with test automation is that we want to verify our logic. We don't want to verify the logic of the service. Of course, we once in a while need to test the full Monty. We need to execute the whole scenario, really calling that service. But let's say nightly or pull request builds that are run, we probably don't want to test the full Monty, having the risk that a pull request is not accepted because the service is not there, and the rest actually is still okay. So for those kind of tests, we want to test double that external service. The example I'm going to use is actually the example that I also use in chapter 13 in the book. But in the book, I did not pick up the interfaces. The scope of the book was, let's say, set, and going into chapter 12 and 13 was already a big extension to the first edition of the book. And I decided to do it in a simpler way at that time. And here in this process, which is standard in BC, and I will explain a little bit more, there is this component that is going to call the service and it gets a response. I solved it in the book by replacing the code unit, so calling up a code unit and configure it to direct to another code unit ID and execute that code. That was a version of how I implemented, and I also used a publisher and then subscribe to that publisher and handle this true, so that the standard code did not needed to be executed. I did it also that way because the standard code was not using an interface. So I already had to update standard code or adopt it and tweak it a bit, but I didn't want to go too far off of the standard implementation. So with this presentation, I'm going to do that differently. You could say I'm again adopting the standard code, but I implement it. It's not a code unit with an on-run trigger. It's now going to be a code unit which is implementing an interface. Yeah, and that's what I'm going to show you. About this small example, let's get to the application here. The example is the EU VAT registration number validation. It's calling a service from the EU, and that service, given a country code and a VAT registration number, is going to return to me the information related to it, the owner of that VAT number. Or if it's an unvalid VAT number, it's going to tell me that it's false. It's not okay. This service, this is standard BC, is not enabled. If I am going to use this, and I could use this on a customer record, then if the service is not enabled, yeah, I could well, let's create a new one here, and I don't know, let's make this one. Okay, and let's give it a name for today, and here I should be able to know where this is one registered. I actually wanted to demo to, oh yeah, it's here. Yeah, so here I could fill in, for example, a Dutch one with some numbers, and this one is going to tell me, based upon the country region settings, that this is not a valid format, but it's not going to check anything in through the service. Yeah, so what I did, by the way, to make it a bit simpler, is that I have a separate table build, which I called VAT registration numbers. I could have called it simple customer. It's just a table having a primary key, a country region code, and a VAT registration number. So the service is on right now, yeah, and I'm going to create a new one. Let's say customer 1 in the Netherlands, and yes, the Dutch VAT starts with NL, and if I again just type in something, I probably get a warning from the country region settings. Yeah, a similar thing like that. I do have here a valid VAT number. So if I put that one in, it's also going to call the service. So on one hand, it's going to check locally, is this the right format from the country region setup? And then once that's approved, you could say it's going to call upon the service. And as you can see, it's waiting for the service to respond. And we're lucky today. Well, every time I do this, I check it somewhat before, of course. I checked it this morning, it was working. And then often when I demo it, it's not working, but it's working. This is my company. This is my address. And yes, I do get this back from the service. That's working. But you saw that it took some time. So what I can do is that I could decide to not use the standard one, but to use a mock. Yeah, and in this case, let's use a mock. And this is actually more a stop, but Microsoft use mock generically in various components. So I decided to, let's say, comply with their naming. But this you could better call a stop. I'll show you some of the code. So it's going to use this one. So if, let's say, let's call this cust2, and let's use the same data. Even though this is a valid one, I'm now testing it by using that replacement. And this replacement is going to return a false. This is not, there's no match for this VAT registration number. Quite fast. And yes, the other one, the valid one, is, okay, what's happening here? Okay, oh, of course, with the error. Nevertheless, let's get back. Let's turn on the valid one. This is going to return a mocked, if we want to call it, version of the data the service could return. So it's not going to call the service, but it's just going to act as if the service was called. So here, see, it got a response. I'm using the any library, if you know about that, one of the test libraries of Microsoft, returning a kind of random string to me. And yes, it is showing that my logic is working. I'm providing a country region code. I'm providing a VAT registration number. It's going to execute the code. The VAT registration number is in the right format. You could say it passes by the definition on the country region table or the record for the Netherlands. And then it's going to trigger the logic, or actually the replacement logic of calling the service. Yeah, and this I could do it once again. Let's do it the same one with the original code, or actually the tweaked original code. I'll get into the definition. So here, let's do the first one again. Yeah, with the service, you see it takes somewhat longer. It's not a lot, but that's also one of the reasons. It's not only not loading the external system, not having to pay for the external system, not having the chance that or the risk, you could better say, that service is not available. It's often also taking a little bit of your time. So running it without calling the real service. So let's take the 3 version again, so that we're going to use that, valid one. Yeah, you will see that this one is, wait, not moving back. Do you want to use, no, what do I do wrong? Wrong key combination. So I'm using the same one and it's somewhat faster. Yeah, so there are a number of reasons why you want to mock the call of an external service. Yeah, it's the ones I just mentioned. About the implementation. So yeah, this is the interface definition. Actually, I do have here an app, production app, or app as I call it, and a test app. In the production app, I have an implementation of the interface, which is an abstract of code unit 248. Code unit 248 has this code in the unrun trigger. I changed that. So now this is an implementation of the interface definition, which has this method as its contract, you could say. Yeah. So the interface, VAT validation handling interface, is defined by this method. Yeah, not the implementation, but just the API, a check and log VAT number. I called it that way. Probably if I had built this from scratch, I would have done it differently, but this is closest to the standard implementation, being an on-run trigger calling the code here. And here we have this implementation check and log VAT number, where eventually down here, send request to VAT registration service is going to send a request to the service. Yeah. With my tests, I implemented, with my test app, I implemented an extension of the enum, which is related to that interface definition, and I provided the valid and invalid version of a mock. And as you can see, I have 2 code units, the invalid one, which is an implementation of the same interface. And what you see here is that create invalid VAT check response. I'm creating an XML doc, which I'm handing back to the logic, which actually returns as a response a false. Yeah. So, and yeah, it needs to have this root element, but the only thing that's needed to return a false, it's not found, there's no information found for this VAT number, so it's an invalid VAT number. The valid version, however, has also, actually it's more a stub, as I said, it's not a mock. It creates an XML document here with a response true and a name and address. Yeah, and the name and address are provided by my test code. Yeah, or sorry, by my test library call here. So just some values, and I don't care what it is. Using that library as an advantage, I don't need to think about it. And the next time this alphanumerical text will be another one. So if I would repeatedly call it, I would get other values. It's every time starting at the same one, but one after the other, it will call that one. Okay. You're not coming up, David, with any questions? No questions so far?
No, very quiet. No questions at all.
Okay. I think we're nicely on time, a bit ahead of time. The last part I wanted to show is on the testing part. So what do I do with the testing? Let me demo that first. So probably need to refresh, log in again. Oh no, that's fine. So I created 2 tests, which makes use of that dependency injection. So I have a test with a valid VAT registration number with dependency injection, and I have a test with an invalid VAT registration number. As you can see, I ran it already. I could run it again, and you can see that the last one especially is faster than the first one. It's not showing any time, so that's less than 10 milliseconds. So that's a very fast one. And yes, it should then yield every time. As, in the interface, it would show that dialog telling me that it's not a valid VAT number. So in my tests, and let me make a little bit more room here. So here I created 2 tests. The first one, test valid, and the second one, test invalid. And the code of each looks a lot alike. The main difference is that here I'm going to set on the settings, the EU VAT registration service setup. I'm going to set this enum value. So this is going to switch to my valid VAT and check mock. And with the other test, I'm setting it to the invalid one. And the rest partly is the same, of course. It's going to call the code. The difference will be that here I'm going to need to verify that I get a valid VAT registration log entry, and here that I'm getting returned an invalid one. And so I need to fetch the dialog that pops up and check that it's indeed telling me that it's not a valid one. If you have another implementation, of course, the test would be partly be the same. The validation probably will be different, so the then part will be different, but you could easily add different ones as your own test extension or as an extension to the app to allow for other validation services to be called. Here on this side, we have implemented the code so that it can here indeed make a call upon the real service, but or the standard EU service. But if there's another service available, you could extend that and add your own call to the service. So what we did, actually, this is the flow chart. We do enter a country region code and a VAT registration number. The logic is what is implemented already in the standard implementation. I tweaked it to call upon the service through an interface implementation, and this allowed me to replace it by injecting another implementation, or in my case, 2 other implementations as possible injections, the valid and invalid response. Okay. Well, the demo has been done. Both examples can be found on this GitHub repo, AL interface examples. So the one here is the BC example, and the other one is the VAT example I just showed to you. Feel free to use it. I need to update the README to include the VAT example, but there was something left over of this afternoon. So thanks for listening. Any questions? I'm a bit ahead of time, but
Yep.
That's fine.
We have one question.
Go ahead.
Yeah, it's from Peter Conjun.
Yeah.
It says, hi Luke, this injection method depends on the extensibility of enums. What if your app has an enum with interface implementations that you, for whatever reason, do not want to have extensible, but still want to test?
Yeah, you can have internal access, and then you can allow it to access it. Yeah, so you if you are the owner, you have the option to access it through your test app.
Peter, does that answer your question? Yep, it did. So thanks.
Thank you very much. Any other questions, maybe, if people want to pose them? There's some time left.
It seems we've got just one question.
Okay, then that's it. The story doesn't need to be longer than it is.
Mm-hmm.
So.
Thank you, Luke.
You're welcome.
Oh. Yeah, a couple of thanks there from Peter. Very welcome.
I read he's in Dutch, fijne pakjesavond. It's Santa Claus today in the Netherlands, and we call it pakjesavond, which is like, you could say, Boxing Day in the Anglo-Saxon world.
Mm-hmm.
So, I think we're going to end, right?
That sounds very good. Thank you, Luke. I hope everyone can please go to the YouTube page, have a look and watch a replay if you need this, plus all the other sessions. And as we said, anything you come up with you'd like to do a presentation, please get in touch with us. Thanks, everybody. Thank you, Luke.
More than welcome. Thank you, everybody.